Hi, welcome to our math. Today I'm doing a series of videos on polynomials. To give you the basic definition of a polynomial is an expression whose exponents on the variables are all whole numbers, 0, 1, 2, 3, 4, 5. No decimals, no radicals, no negatives, no variables in the denominator. Once we visually can tell what a polynomial is, the next thing we want to do is count the terms. Terms are like little buildings separated by the pluses and minuses. So this polynomial has 1, 2, 3 terms. This second polynomial has 1, 2 terms. This next one has 1, 2, 3, 4 terms. Now terms are not variables. X and Y do not make two terms. This term is made up of the multiplication of 4x and y squared. These last three all have exactly one term. Even though there's a lot of variables, it's still one term. Okay, poly means many. Unknown number. Polynomial is our generic. We can call them all polynomials. When we have three, we can turn our poly prefix into tri, so trinomial. For 2, tri becomes bi, like tricycle, bicycle, binomial. 4, well, the prefix 4 is quadra, so quadranomial. But once we get past 3, we just give everything the generic polynomial. We don't worry about any of the extra prefixes. And 1 is mono. Now mononomial, that's a big no-no in the middle. The no's kind of combine. Monomial. And we do that for all of our single term polynomials. Okay, so now we know how to count our terms and how to name our polynomials. Degree. Degree is actually really important as you move up in math. It's really the degree of unknown. This polynomial has 3 terms, and each of the terms is trying to win to be the definition of what the graph of this polynomial will look like. When the numbers are small, 0, 1, 2, x, those numbers, all 3 terms have a big effect on the final answer. But if our x is equal to 100 or 1,000, suddenly the bigger the exponent, the more power that term has in determining the final answer. So this first term is really 5xxx, and this is really 2xx, and this is 11. This term has 3 unknowns, this term has 2 unknowns, and this one has 0. The degree of the polynomial isn't adding it up, it's the term that defines the overall look of the polynomial, the biggest unknown. So this is a 3rd degree polynomial. Leading coefficient is the number, coefficient means number. The leading coefficient is the coefficient of the term that has the biggest degree. So if this term is the biggest degree, the leading coefficient is 5, and a constant term is a term whose unknown is 0. We know everything about a constant. In this case, it is 11. Okay. This degree, 21t to the 5th. This is a 5th degree term. 17t, this is a 1st degree term. There's 1 unknown there. There are 5 there, which means this is a 5th degree polynomial. The leading coefficient is 21. That's the number attached to the t to the 5th. And the constant term, there isn't one. We could say 0 because we could add a plus 0. We could also say not applicable because there is no constant term on this polynomial. Okay, for this next one, we have 1, 2, 3, 4 terms. This first term has an x and 2 y's. That means it's a 3rd degree term. This has an x and a y, that's a 2nd, 1st, and 1st. Those two match, different variables, but they each have exactly 1 unknown part. The degree is 3rd, 3 wins out. The leading coefficient, the coefficient of the number in the term of unknown is 4, and the constant term will go with not applicable. Okay, monomial, degree. 1, 2, 3, 4. There are 3 x's and a y. That means this is a 4th degree polynomial. The leading coefficient is -15/7. The number part of this is all of that. And there is no constant term. 8. The degree of this is 0. This is a 0 degree polynomial because there isn't anything we don't know about this polynomial. The leading coefficient, well, it's 8 because that's the only coefficient, and my constant term is 8. And then this one, z, is z to the first. That's a first degree monomial. The leading coefficient is 1 because there's always an implied 1 times. Even if you don't see the 1, there is a 1 there. And the constant term, there is none, not applicable. Okay, I hope you've enjoyed the video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.